Ever tried reading a mystery, like midway through, and you're just totally lost?
Yeah.
That's basically what we've been asking computers to do with language forever.
Right.
Getting them to understand the nuances of a really complex sentence, especially a long one.
Yeah.
It's like solving a jigsaw puzzle, but with, like, half the pieces missing.
It's true. And that's where this paper, Attention is All You Need, comes in, right?
Okay.
It's not just a catchy title.
Right.
It marks a real turning point in how we can actually teach machines to understand language.
Okay, so let's unpack this a little bit. The paper introduces the transformer model, which sounds simple enough, but my guess is it's anything but.
Yeah, you would be right about that.
Okay.
So before the transformer, imagine you're trying to get a computer to understand a sentence like,
Okay.
the cat sat on the mat, even though it was covered in crumbs.
Okay.
And it's not just about, like, knowing the words, right?
Right.
It's about understanding how, like, it refers back to the cat and how that, like, changes the whole picture of what's going on.
Yeah, those long-range dependencies, as they're called, they can really trip you up.
Yes.
So how did they solve that?
So they basically threw out the old playbook.
Okay.
So before this, recurrent neural networks, RNNs, were kind of like the go-to for processing language, natural language. But they had a lot of limitations, right? One is that they were super slow.
Okay.
Like, imagine reading that mystery novel, but like word by word by word.
Word by word, yeah.
And then also, RNNs were really prone to, like, forgetting. Like, you read something important at the beginning,
Right.
but then by the time you get to the end, you're like, wait, who is that character again?
Right.
They would kind of forget these crucial details from earlier in the text.
So what did they replace these RNNs with?
So enter the transformer.
Okay.
So instead of processing information like sequentially, one word at a time, the transformer uses something called attention to kind of like focus on the entire sentence all at once.
Okay.
And that's how it captures these like really important like long distance relationships.
Okay, now hold on. Back up.
Okay.
Attention.
Yeah.
What does that even mean in this context? I mean, I can pay attention.
Right.
My dog, not so much.
Well, right. Good point.
Okay.
So attention in like the AI world basically means that the model can like focus on specific parts of the input, right?
Yep.
Based on how relevant they are.
Okay.
It's kind of like how our eyes, they dart around when we're like looking at a scene, trying to understand it, right?
Yeah.
So it's like certain things pop out to us.
Okay, so instead of reading a mystery novel word by word, the transformer is like piecing together all these different clues from the entire story at once.
Precisely. And the way it actually does this is through something called scaled dot product attention, which might sound a little crazy.
Yes, scaled dot product attention.
Like something out of Star Trek, but
right, exactly.
It's actually a really clever way to calculate what you could call a compatibility score between every single word in the sentence.
Compatibility score, like how much each word kind of vibes with the other.
Yeah, exactly. And so a high score means that those two words are like really strongly related, even if they're like really far apart.
Okay.
And then the scaled part is important because it basically prevents these scores from like going crazy when you have really, really long sentences. Like imagine trying to like keep track of all the characters in like a Tolstoy novel.
Right.
Like,
okay, this is already kind of blowing my mind. But the paper, it doesn't stop there, right? They talk about multi-head attention.
Yeah.
Which just sounds intense.
It is. So imagine instead of having like just one detective working on our mystery, we have a whole team.
Okay.
And each detective has their own like specialty.
Right.
So that's kind of like multi-head attention in a nutshell.
So like one head might be great at figuring out the timeline.
Exactly.
Another is like really good at spotting character connections.
Yeah. Exactly. Okay. So each head focuses on like a different aspect of the sentence, right? Okay. So it could be grammar, meaning like how words relate to each other. Okay. But we end up getting like a much richer understanding of that text.
It's like having multiple perspectives to solve that puzzle.
Exactly.
Which makes sense.
Yeah.
Even in like my everyday life.
Right.
If I'm trying to understand something complex,
Yeah.
I try to look at it from different angles.
Absolutely, yeah. And this like multi-headed approach, this was a game changer.
Okay.
Because it allowed the transformer to like grasp nuances.
Okay.
And make connections that like previous models just they couldn't.
Right.
It's really about understanding that full story,
Okay.
not just the individual words.
So this whole attention thing, it sounds incredibly powerful.
Yeah.
But did the researchers just talk the talk? Or did the transformer actually walk the walk?
Oh, no, they had the results to back it up.
Okay.
And they actually highlight in the paper some like major advantages of the transformer over, you know, those old RNNs.
Right.
And it's not just like a little bit better.
Okay. What is the complete game changer?
Okay, well, hit me with the highlights then. What makes the transformer so revolutionary? So first off, it's all about speed.
Okay.
Remember how we talked about RNNs being like reading a sentence like word by word by word?
Yeah.
Okay, so the transformer is like having a whole team of like speed readers that are all working in parallel.
Okay.
So it's just incredibly efficient, especially when you're dealing with these really, really long, complex sequences.
Okay. So faster processing. Got it. What else?
So they also tackled that like long-range dependency problem head-on, right?
Right.
So with RNNs, there was always this risk of like the model, like forgetting something important from earlier.
Right.
But with the transformer, because it has this attention mechanism, it basically has this amazing ability to like remember everything it's seen, no matter how long the sentence gets.
Like it has a photographic memory.
Yeah.
For language.
Exactly.
That's incredible. But this paper, it focuses specifically on translation, right?
Mm-hmm.
Did they actually like test this thing out?
Oh yeah.
In the real world?
Yeah, and the results were mind-blowing. So they pitted the transformer against like the at the time state-of-the-art translation systems for like English to German, English to French. And it just like blew them all out of the water, like much faster translation times, higher accuracy.
Right.
It was like a clean sweep for the transformer.
Okay, so we've established that the transformer is a rock star.
Yeah.
When it comes to translation.
Right.
But I kind of can't shake this feeling that this technology probably has implications.
Yeah.
Far beyond just switching between languages.
Okay.
Am I onto something here?
Yeah, you are totally right. And they even hint at this in the paper. They actually mention applications in, like, they specifically say constituency parsing.
Okay, constituency parsing.
Yeah.
That sounds a little intimidating, even for this deep dive.
So it might sound a little intimidating, but it's actually much cooler than it sounds, I promise.
Okay.
So imagine you have a sentence like, the quick brown fox jumped over the lazy dog.
Okay.
Okay, so constituency parsing is all about figuring out like the grammatical structure of that sentence. Like how do all the words actually group together to create meaning?
Got it.
Right. So instead of just seeing like the quick brown, it understands like the quick brown fox, that's like a noun phrase, that's one unit.
Okay.
Jumped over is a verb phrase.
Okay, I see. So it's so the transformer can not only translate the words, but it can also like understand the underlying like grammar and structure of the sentence itself.
Exactly.
Okay. That's pretty remarkable.
It is. And here's like the really mind-blowing part. The paper suggests that this transformer technology isn't just limited to text.
Okay.
They believe it could be applied to images, audio, even video data.
Whoa, hold on. We were just talking about like understanding sentences.
Yeah.
And now we're talking about like pictures and sounds.
I know.
That's wild. How does that even work? Does the transformer like learn to read images?
That's the really cool thing about this whole approach.
Okay.
So think of it this way, right?
Okay.
Just like a sentence is a sequence of words.
Right.
An image can be seen as a sequence of pixels, right?
Okay, yeah.
And then audio is just a sequence of like sound frequencies.
Okay.
So the transformer doesn't really discriminate, right? It's all about finding patterns and relationships within sequences.
Okay.
No matter what that data actually is.
So the transformer is like the ultimate multitasker of the AI world.
Exactly.
It can analyze text, decipher images, maybe even compose symphonies someday. Who knows?
Exactly. And that's what makes this research so groundbreaking, right? It's not just about like, oh, we made this thing 10% better.
Right.
It's a fundamental shift in how we're approaching machine learning.
Right.
And it has the potential to like revolutionize, a vast array of fields.
This is incredible. We started with computers, like struggling to understand basic sentences.
Yeah.
And now we're talking about them like potentially decoding the entire world around us.
I know. It's pretty amazing.
Okay, so I think I'm starting to wrap my head around like the sheer power of this thing.
Yeah.
But there's something you mentioned earlier that I kind of wanted to circle back to.
Okay.
You said that we can actually visualize what's happening inside the transformer.
Yeah.
Like we can peek into the AI's brain.
It's true. It's one of the things that makes this so remarkable. So remember how we were talking about those attention mechanisms and how they calculate like those compatibility scores between all the different words?
Yeah.
Well, researchers can actually take those scores and plot them visually so they can create like a heat map that shows you which words the model is actually focusing on when it's like reading and processing that sentence.
So you can literally see like the words lighting up in the AI's mind.
That's a great way to put it, yeah.
Okay.
You can see like what it finds important. And the paper actually, they show a bunch of these visualizations.
Okay.
And they're super insightful. Like you can see how the transformer can connect words and phrases that are like pages apart effortlessly, something that like an RNN would just completely trip up on.
Wow. That's amazing. It's like X-ray vision into the AI's thought process.
Exactly. And it's not just about seeing like which words are connected, right?
Okay.
Because remember we talked about those multiple attention heads?
Right.
Like each one has its own kind of like area of expertise.
Right.
So the visualizations can actually show you which parts of the sentence each head is focusing on.
Wow.
Right? So one head might be really into the grammar, another head might be picking up on like the emotional tone.
Okay.
So you get this like multifaceted view of how the AI is actually processing that information.
That's incredible. It's like having a window into the AI's like inner workings, which is usually a bunch of mystery.
That's a black box. Yeah.
That's a black box. Okay. So
and this is a big deal.
Yeah.
Like this interpretability, it's a huge part of why this whole thing is so revolutionary. Because it's not just this like black box spitting out an answer. We can actually start to understand the why behind it.
Okay. So let's kind of recap here.
Okay.
For all our listeners who are probably just as amazed as I am right now.
Yeah.
So this attention is all you need paper.
Yeah.
Introduce the transformer, which uses these incredible attention mechanisms, to basically revolutionize how computers understand sequences. It's faster, it's more accurate, but probably most importantly, it's way more interpretable.
Yeah, you got it. It really was a paradigm shift. In AI.
And the crazy thing is, this is just a tip of the iceberg, right?
Yeah.
The paper hints at applications way beyond like language translation.
Absolutely, yeah.
Analyzing images, audio, maybe even like understanding video someday. Who knows?
Who knows what else? It's really exciting.
It is exciting. It really is. So to wrap things up here, it makes you think, right?
Yeah.
If this one paper can have such a massive impact
I know
on how we approach AI, what other like long-held assumptions are out there?
Right, exactly.
In other fields, that could be, totally disrupted.
There's that classic thing of like sometimes the biggest breakthroughs that come from just asking a different question.
Exactly.
Like, what if we try it this other way?
What a fantastic point to end on. This has been a deep dive.
It has.
For the ages.
Thanks for joining me on this journey into the heart of the transformer.
The pleasure was all mine. Always happy to geek out about a paper that like really changed the game.
Until next time, keep those minds curious and remember, sometimes the most groundbreaking discoveries are just a shift in attention away.